Good morning. We're going to continue onward, and this time we're going to go from moles of a substance to grams of a substance. So, just like last time, you still have to find the molar mass, but we're going to go backwards this time. So, if we look up xenon on the periodic table, it's 131.29. And so we can do the ratio or the multiplying, or you can just set up a proportion or multiply the ratio as always. So we'll do it the other way this time. If you got 2 moles of xenon, you're looking for a given number of grams of xenon. It's got to be equal to the ratio of molar mass. So we got 1 mole for 131.29 grams of xenon. So you're going to cross multiply, and we're going to end up with 262.58 grams of xenon times moles of xenon, which is equal to x grams of xenon times 1 mole. Excuse me. Well, not really 1, but moles. Xenon. We're going to divide by that 1 here, 1 mole, to cancel out moles. So our mole cancels out, mole, mole. We are left with our x in grams is equal to 262.58 grams of xenon. Okay. As always, you can also just set it up where you've got 2 moles and multiply the ratio where 1 mole has a mass of 131.29 grams as well. And that'll give you the same number. Remember, it's going to be opposite of last time. Is you start with moles and you need to cancel moles out. So moles is going to go on the bottom. To figure out the mass of 0.7 moles of aluminum oxide, you have to figure out the formula first. So if you look at aluminum, it's in the 13th column, which means it's going to have 3 valence electrons, which it'll lose when it forms an ionic compound for a +3 charge. Oxygen, of course, is in the 16th, so it's going to gain 2 to get to that full octet. We know we can just cross them down because if you have 2 aluminums, you're giving up 6 electrons, and if you've got 3 oxygens, it's going to take 6 electrons, and so we are a neutral compound at that point. So to find the molar mass, you've got to multiply 2 times the molar mass of aluminum, which is 26.98. We're going to call it 27. And because oxygen's got a 3, we're going to do 3 times the molar mass of oxygen, which is 16. So the molar mass of aluminum oxide is 102 grams per mole. So to get to the mass, we're just going to start with the number of moles we have. And we're going to multiply by that ratio, and we need to cancel out moles, so 1 mole will go on the bottom, 102 grams on top. So if we multiply 102 by 0.7, we end up with 71.4 grams of aluminum oxide. As always, good luck, have fun, everyone.